Hello friends, welcome you all. So today's topic is conversion of regular expression to DFA. Conversion from regular expression to DFA. So as you can see here, there are two methods for converting regular expression into DFA. One is direct method where we direct convert regular expression into DFA, and one more method is that is some longer method. And here in this method, regular expression is first converted into NFA with the epsilon move. Then this NFA with the epsilon move is converted into NFA without epsilon move. And then finally this NFA is converted into DFA. So there are these two methods are there by which we can convert regular expression into DFA. So in this video, we will discuss the direct method first, and then in next video we will discuss the longer method of conversion. So we will start with direct method of regular expression to DFA conversion. So friends, these are the steps of converting regular expression into DFA direct method. Now these are all steps we will see one by one. First step is put an extra symbol hash at the rightmost position in the regular expression. Put an extra symbol hash at the rightmost position in the regular expression. This hash symbol is added there to identify the final state in the DFA. To identify the final state in the DFA, and when I take some example there, and when we will convert any regular expression into DFA, then it will be more clear. So for now, you can understand that hash symbol is added to identify the final states in the DFA, and this is placed at the rightmost position in the regular expression. Then second step, number all the input symbols from left to right starting from 1, and we have to number all input symbols. Remember friends, you don't need to number operators. I am calling only input symbol. I am telling only input symbols. So all input symbols must be numbered from left to right, starting from number 1, and then you can increase one by one, and also consider hash that you have added as extra symbol in the regular expression as input symbol. So this hash will also be numbered. This hash will also be numbered. Then third step is find first pause and follow pause set for the regular expression, and then in fourth step we create DFA using first and follow pause set found in the step 3. So these four steps are there to convert a regular expression into DFA using direct method. Now we will see, we will implement all these steps, and I will take one example there to explain this process very clearly. So for now, I can take some example like suppose you are given expression as a plus b whole clean closure of a plus b or whole asterisk a b a b. So suppose this regular expression is given to you. So as first step, you need to add one extra symbol here as a hash, which is placed at the rightmost position in the regular expression as the first step. Now in second step, what we do, we number all input symbols. So input symbols are two input symbols are there in this regular expression, and one more input symbol, extra symbol we have added here as hash. So we will number all input symbol starting from 1 from left position. So this would be 1, this would be 2, this would be 3, this would be 4, and this hash would also be numbered as 5. So this is the way you number all the input symbols in the regular expression. So this completes your step 2. Now How to find first pause and follow pause and what these sets are, that I will discuss. So friends, I hope these two steps are clear. Now I will take third step in detail. So friends, you can see here what are first pause and follow pause set. So first pause set is, it is the set of all numbers assigned to input symbols that may appear at the first position in all possible strings created from given regular expression. So first pause set is found for complete regular expression. For complete regular expression, only first pause, single first pause we will find for regular expression. Now uh, follow pause is found for each symbol, each input symbol, that many numbers we have assigned to input symbol. For all input symbols we find follow pause set. Now follow pause set for any symbol is the set of all numbers assigned to input symbols that may appear after this symbol in the all possible strings created from this given or regular expression. So these are the definitions of first pause set and follow pause set, and I will take the example of saying, and we will create first pause and follow pause set for any regular expression as example, so it will be more clear to all of you. Now we will start with any example regular expression and we will create DFA for this. So now friends, we will take one regular expression as example and we will start converting it into DFA. So I'm taking one regular expression as a plus b whole asterisk ab. This is the regular expression for representing all strings of A and B ending with AB. All strings of A and B ending with AB. So we need to convert this regular expression into DFA using direct method. So now we will apply the steps of conversion one by one. So as first step, I will put one extra symbol here as a hash, so that I have done. This completes our first steps. In second step, we number all the input symbols from left to right, starting from 1. So this is number 1, this is number 2, this is number 3, this is number 4, and that hash is also considered as input symbols. So I will number it also as 5. So I have numbered all the input symbols. As third step, we will find first pause set and follow pause set. So as I told you, like first pause is found for complete regular expression. So in all possible strings of this regular expression, what we can get at first position, so that would be your first pause, and we will create a set of numbers assigned to input symbols. So now first pause of this regular expression is, first pause word is, see, in this regular expression, at first you can have any number of any combination of A and B. You can have any combination of A and B using this particular bracket or this particular clean closure. Now, if this clean closure is considered as epsilon, as it is clean closure, so this may be epsilon also. So if this is epsilon, then this symbol will be at the first position. This symbol will be at the first position, which is numbered as 3, which is numbered as 3. So if this is considered as epsilon, then you can have 3, the shortest string of this set would be AB. So in this condition, 3 would be at the first position. Then A, which is assigned number 3, would be at first position. Now if we consider at least one symbol from these two, this clean closure set, so we can have either A or we can have B. So if we have A, then complete string would be AB, AAB. And if we have B from this clean closure, so complete string would be at BAB. So in this case, you can understand this A is coming from this bracket or this clean closure. That means this A is representing symbol 1. So I can add 1 here in first pose of regular expression. Now, if we are considering only single symbol as B from this clean closure, so this would be considered as 2. This would be considered as 2. So only 1, 2 and 3 that can appear at the first position in all possible strings of this regular expression. Now you may have some questions like why we have not included 4. So you can see, my friend, this AB is compulsory string. This AB is compulsory string. And if this is compulsory string, then always this A will be there before B. So B cannot be at first position in any string from this regular expression. So we have not included in first set of this first pos set. So all possible symbols are 1, 2 and 3. We create the set of numbers assigned to input symbols as I have told you in the definition. Now this is found for complete regular expression. Now first follow pause is found for each symbol. Each symbol. So we have here 5 symbols. We have here 5 symbols. So now we need to know what would be the follow pause of each symbol. So now first we are trying to find follow pause of 1. Follow pause of 1 means the follow pause of this input symbol where we have assigned number as 1. So follow pause of 1, that would be how we can find it. So now we need to know all possible strings from this regular expression. So now if this we are finding the follow of this A, that means at least one symbol must be there from this clean closure. So in this case, you can see if we have A, only A from this clean closure, so this would be 1, this would be 3 compulsory A, and this would be 4 compulsory B. And now in this case, which symbol is following A? It is 3. So we can include 3 in follow pause of 1. Now from this regular expression, other strings are also possible, like if we have A, 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 B. That means what? This AB is compulsory, this compulsory string. So this is 3, this is 4. This is 3, this is 4. Now these two A have come from this particular clean closure. So now if they are coming from this clean enclosure, so both these A are 1 only. Now you can see, my friend, which is following 1 here. 1 is following itself. So we can include 1 in the follows for set of 1. Now, my friends, I can take one more example from this clean closure. If we create AB, then this would be AB. Then this is compulsory string, so which is 3 and 4. Now this AB is coming from this clean closure. So the A inside clean closure is 1, B inside clean closure is 2. So in this case, you can see, my friend, 1 is followed by 2 also. 1 is followed by 2. So we can include 2 as follow of 2. Sorry, follow of 1. 2 as follow of 1. So now you can see, my friend, now In follow of 1, we can have 1, 2 or 3. 1, 2 or 3. All three possible possibilities are there for follow of 1. Now, similarly, we will find follow pause of 2, follow pause of 3, 4 and 5. So now we can see follow pause of 2. Follow pause of 2, again you can see my friend here. Now again I'm taking some example here. So in all possible strings of this, if we are we are finding the follow of 2, then there must be at least one symbol from this clean closure. So if we have only B from this clean closure, and then compulsory string would be AB. So in this case, this compulsory string is AB, which is 3 and 4. And this B is coming from clean closure. So inside clean closure, the number assigned to B is 2. So that means 2 is followed by, in this case, 2 is being followed by 3. So we can include 3 in the follow of 2. In the follow of 2. Now, some more possibilities if we can find. Yes. So if I get BA, AB, this string from this regular expression, and which is valid string from this for this regular expression. So this AB is compulsory string. So this is 3 and 4. Now this BA is coming from clean closure. This BA is coming from clean closure. So number inside assigned to B inside clean closure is 2, and number assigned to A inside clean closure is 1. So now in this case you can see my friend 2 is followed by 1. 2 is followed by 1. So we can include 1 in the follow of 2. Now we can take one more example. Now if we have BBAB, BBAB, which is valid string from this regular expression. Now if we see AB is compulsory string. So compulsory string is 3 and 4. So compulsory string is 3 and 4. Now this BB is coming from this clean closure. And inside clean closure, B is assigned as 2. So these two B's are from the same number. 2, 2, 3, 4. Now you can see my friend, 2 is followed by 2 itself. 2 is followed by 2 itself. So now we can include 2 in the follow of 2 again. 2 in the follow of 2 again. Now, I hope it would be very much clear to all of you. Now, I will take one more follow of 3, follow of 4, follow of 5. So I can now find follow pause of 3. Now, this would be, see, this A, which is assigned a number 3, this is compulsory A. And after this, compulsory B is there. So only this B will be following this A. That means always 4 will follow 3, or you can say 3 will be followed by 4 only. So this is the only symbol in the follow of 3, follow pause of 3. Now we can find follow pause of 4. So follow pause of 4. Follow pause of 4. Now again you can see my friend, follow pause of this B is compulsory symbol. B is compulsory symbol which is assigned 4. So now which is what is following 4? The hash which we have added as extra symbol, and the number assigned to this hash is 5. So follow of 4 would always have only one symbol which is 5. Now we need to have follow pause of 5 also. So we will calculate follow pause of 5. So in follow pause of 5, you can see my friend, nothing is following hash. Hash is the last symbol, so nothing is following hash. So hash, so follow pause of 5 would be 5. follow pos of 5 would be 5. So these are the first pos and the follow pos of this regular expression. First pos and the follow pos sets for this regular expression. I hope, my friend, it would be very much clear because I have taken each possibility with the example. So it would be very much clear. Now I will, using all these first and follow pos, I will show you how to create DFA. So now friends, we will create DFA using these first pos and follow pos set for this regular expression. Now, in every DFA, there is one state called initial state. So here we will use first pos of regular expression to create initial state. So in first pos of this regular expression, three symbols are there, 1, 2 and 3. So we will create one initial state which will have 1, 2 and 3 as symbol, and this would be considered as initial state. This would be considered as initial state. Now, all possible symbols are A and B only. There are two input symbols only. That hash we have considered, although we have considered as input symbol, but in original regular expression it was not given. So we have added it as extra symbol to identify the final state only. So in original regular expression, only two symbols were there, like A and B. So we need to see both transition for A and B from this state. So now how to see the how to create the transition or for A and B from this state, that we will see. Now to create the transition of A from this state, we need to see how many numbers within this state we have assigned to A. So out of 1, 2 and 3, we have assigned two numbers to A, like 1 and 3. 1 and 3 we have assigned to A. So we will take follow pos of 1 and the follow pos of 3, and we will take the union of these two sets, and we will create one new state if it is new. So we will create one transition like this from A, follow as we have assigned 1 and 3 to symbol A in a regular expression. So the follow pos of 1 is 1, 2, 3, and the follow pos of 3 is 4. So union of these two would be 1, 2, 3, 4. So this state we have not created yet in the DFA. So we will create one more state here with 1, 2, 3, 4. So this would be another state. And now we need to see the transition of B from this state. So we will see how many numbers we have assigned to B out of these three numbers. So we have only one number assigned to B, which is 2. So follow pos of 2 would be considered as there. So we will take the follow pos of 2. So in follow pos of 2, we have 1, 2 and 3. Now check whether this state has been created already or not. If it is created, so use the same state. If it is not, then you can create new state. So follow pos of 2 is 1, 2, 3, and 1, 2, 3 we have already created. So on the transition of B, we will use this state only. So for B, we will create one self loop on this state. Now we have seen both the transition of A and B from this state. Now which new state we have got? So we will now try to create the transition of A and B from this state. Now if we consider this state, the transition of A we can have, like, how many number out of these four numbers, how many numbers we have assigned to A? So we have assigned 1 and 3 to A in a regular expression. So now we can again take the follow of 1 and the follow of 3 to see the transition of A from this state. So follow of 1 is 1, 2, 3 and follow of 3 is 4. That means the union of these two would be 1, 2, 3, 4. So we have already created this state. So we can stay on this particular state on transition of A. On transition of A. Now, to see the transition of B from this state, we need to know how many numbers we have assigned to B out of these 4 numbers. So we have assigned 2 and 4 to B in the regular expression. So we will take the follow pause of 2, which is 1, 2, 3, and the follow pause of 4, which is 5. We will take the union of these two. So this would be 1, 2, 3, 5. And that state we have not created yet. So we will create one more state here as 1, 2, 3, and 5. So this would be another state, and that would be the transition of B from this state. Now we have considered both the transition for this, both the transition for this. Now new state we have got this. So we will create the transition of A and B from this state also. Now you can see, to see the transition of A, again we will see the number assigned to A. Again we have only 2 numbers assigned to A. That means 1 and 3, and the follow of 1 union follow of 3 is 1, 2, 3, 4. So again we have already created this state. So on transition of A, we will go back to 1, 2, 3, 4. We will go back to 1, 2, 3, 4. Now on transition of B, where we will be moving. So now, how many numbers out of these 4 numbers we have assigned to B? So only 2 we have assigned to B in the regular expression. 5 is assigned to hash, which is not B. So only 2 we have assigned to B in the regular expression. So follow of 2 is 1, 2, 3. Follow of 2 is 1, 2, 3. So 1, 2, 3 we have already created. So we will create one transition of B from this state to 1, 2, 3. Now we have considered both the transition for this. We have considered both the transition for this. We have seen both the transition for this. So now no new state we have got. So that means we have completed the creation of DFA. Now only remaining thing is to decide the final state. To decide the final state. So now my friend, what number you have assigned to hash, that number, in which state that number is appearing, you can consider all these states as final state. So we have assigned 5 number to hash in this particular example. So now we can search for 5. In which state 5 is there, this would be considered as final state. So we have only one state where 5 is there. So this will only be the final state in this particular DFA. Now you can see, my friend, this is the final DFA. This is your initial state, this is intermediate state, this is final state. So we have only one final state, and we have seen all the transition from this particular. Now you can see it will accept all strings of A and B ending with AB, ending with AB. So this would be the DFA for this regular expression. Now, if you want, you can rename all these states. So 1, 2, 3, 1, 2, 3 you can rename as Q0. 1, 2, 3, 4 you can rename as Q1. And 1, 2, 3, 5 you can rename as Q2. So again, that DFA you will find. So this is the final DFA for this regular expression. So I hope, friend, it would be very much clear to all of you. And again, you can always write to me in comments in case of any doubt. Now I will take some more example of regular expression, and I will tell you the possibilities to create DFA. So now friends, if we consider this example, here I have taken one different regular expression, which is 0, then this is compulsory 0, and then positive closure of 0 plus 1, and one more compulsory symbol is 1 there. So this was the original regular expression. Then I put one extra symbol there as a hash at the end of regular expression. Then I numbered all these all these input symbols. So 1, 2, 3, 4, 5. Now in given regular expression, input symbols were 0 and 1. So we need to see the transition of 0 and 1 from each state. Now you can see, my friend, as this is compulsory 0, so this cannot be removed. So this would be always at first position of this regular expression, or any string in from this regular expression. So in first pause of this regular expression, only one symbol would be there, which is 1. One symbol would be there which is assigned to 1. So now you can take this first pause as initial state. Now follow pause of this number, see, follow pause of 1 we can take from here. Now this is positive closure, so at least one symbol must be there from this bracket. So if we have only 0, so 1 will be followed by 2. If we have only 1, so 1 would be followed by 3. So I have included this 2 and 3 in follow pause of 1. Now follow pause of 2. In follow pause of 2, that positive closure of 0 and 1 can generate 0, 0, 0, 0 also. So if 0, 0 is there, so 0, both 0 will be assigned as 2. So 2 will be following 2. Now if we generate 0, 1 from this particular positive closure, so 2 will be followed by 3, and if we generate only 0 from this positive closure, so 2 will be followed by 4. So in all possible strings of this particular regular expression, 2, 3 and 4 will be following 2. So in the same way, we can have follow of 3 as a 2, 3, 4 again. Now how? If we generate only 1 from this positive closure, so 3 will be followed by 4. If we generate 1, 0 from this positive closure, so 3 will be followed by 2. And if we generate 1, 1 from this positive closure, so 3 will be followed by 3 itself. So all three symbols will be there in follow of 3 also. Now follow of 4, as 4 is compulsory symbol. 4 is compulsory symbol, and it is the last symbol of given regular expression, and it is followed by hash that we have added as extra symbol. So only this 5 would be in the follow of 4. So this is the only symbol in the follow of 4. Now follow of 5 is 5, as this is the number assigned to hash, so it is always 5. So these are the first pause and follow pause sets for this regular expression. Now using all these sets, I have created one DFA for this. So as we have first pause, only one state and only one symbol in first pause, so we have created initial state with 1 only. Now to see the 0 transition, we have one number we have assigned to 0. So on this state, if we see the transition of 0, so we will take the follow of 1. Follow of 1 is 2, 3. So 2, 3 is not created here, so we will create one more string as state as 2, 3, and that on 0 transition from 1 we will move to 2, 3. Now 2, as there is no number which is assigned to 1, so we will not create any transition of 1 from this state. Any transition of 1 from this state. So now we will see that both the transition for both the symbol from this state. So 2 and 3 we have assigned 2 to 0. So now to see the zero transition, we will take the follow of 2. Follow of 2. So follow of 2 is 2, 3, 4. So this state has not been created here. So we will create one more state here, 2, 3, 4. And this would be the zero transition from this state. Now, to see the transition of 1 from this state, 3 we have assigned to 1. So we can take the follow of 3. Follow of 3 is again 2, 3, 4. So that's it we have already created. So for both the state, for both the input symbol, the transition would be going to the same state, 2, 3, 4. Now 234 is now new state, and for this we need to see all the transition. So now to see the zero transition from this state, we can see the number assigned to 0. So out of these three numbers, we have only one number, which is 2, we have assigned to 0. So follow of 2 is 234. So on zero transition from this state, we will stay on the same state, and now we will see the transition of 1 from this state. So 3 and 4, two numbers we have assigned to 1. So now we will take the follow of 3 union follow of 4. So that would be 2, 3, 4 and 5. So that state we have not created here. So we will create this state, and we will make the transition of 1 from this state to this state. Now we have considered both the transition for this state. Now we will see this is the new state. So we will see the transition of 0 and 1 from this state. Now to see the transition of 0 from this state, again we need to see the how many numbers we have assigned to 0. So only 2 we have assigned to 0 in the regular expression. So follow of 2 is 2, 3, 4. So 2, 3, 4 we have already created. So on 0 transition from this state, we will go back to 2, 3, 4 again. And now for one transition, the transition of 1, we will see how many numbers we have assigned to 1. So 3 and 4 we have assigned to 1. So follow of 3 is 2, 3, 4, and follow of 4 is 5. So 2, 3, 4, 5 would be the union, and this is the same state. So on one transition, for the transition of 1, we will stay on the same state. Now we have seen both the transition for this state, both the transition for this state, both the transition for this state, and both the transition for this state. As we cannot create the transition of 1 from this state, so this is the final DFA for this particular regular expression. Now in that case, where we are having one compulsory symbol at first position, so in such case, my friends, sometimes we need to add dummy state in that particular DFA that we have created from regular expression using direct method. So if the transition of B is not there, but there is some possibility that user may input B. So we can have on transition of B from this state, we can have one dummy state here as a D, and now that will have, this is not the final state, and that will have all the self loop for all the input symbols. So 0, 1 we have created. This is dummy state. So at first place, if we found B, so that string cannot be accepted then. So this would be going to the dummy state, and this is now the final DFA for this particular regular expression. So sometimes, my friend, you need to add dummy state in case where your regular expression has having compulsory symbol at first position. So I hope, my friends, this would be very much clear to all of you, and in case of any doubt, you can always write to me in comments. I will definitely reply your comments. So friends, now I will take one more example of regular expression to show you a special condition. So now if you have such regular expression like a b star plus b a star. Now this regular expression is having two choices. Either you can create any strings from this set, or you can create any string from this set. So as the choice is there, so when you try to add hash symbol here, you cannot directly add the hash symbol like this, because this would consider like you are adding the hash symbol at the end of this regular expression only. So as complete regular expression is this also, so you must include bracket before adding that extra symbol hash. So this is the special case when you are having regular expression where you which is offering two choices or three choices or four choices. So you need to include all choices in bracket, then you can add extra symbol hash at the end of this bracket. So this was the special case. So in case you are getting like any regular expression like this, you can use this. Now I would recommend you all to create DFA for this regular expression. And if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you so much.